In this video, we'll talk about how to perform in-order traversal in an iterative manner. So if you remember when we did in-order traversal over a binary tree in a recursive manner, our logic was to check if our node is null. If it was, then we just returned. Otherwise, we performed the in-order traversal of the left subtree. And once we finish that, we performed the node specific action for this traversal, and then we did the in-order traversal of the right subtree. So that was our in-order traversal in a recursive manner. And now we want to perform this in-order traversal using the iterative logic. So now I'm going to have in-order iterative given a particular node. And what I'll do is I'll point to the current node that I'm exploring. So let's call it current equal to the node that I am going through. And then I'll have to iterate through my tree. Okay, so let's write down a looping construct while, and we'll need certain condition to be checked. Okay, so let's write down that condition after a while. Okay, but what should be the logic? Okay, so whenever I encounter a node in my in-order traversal, what I should do is I should remember that node and I should go to the left, right? Because that's what is the in-order traversal. First you have to perform the in-order traversal for your left subtree, finish that, and then do the node specific action. Okay, so what I will do is to remember this node because I have to proceed with the in-order traversal of left subtree, but I have to remember the node. So for that I'll use a stack. So let's say I have a stack S, and let's create the stack S dot create new, and the capacity I will need will be again the number of nodes that are there in my tree. So in the previous method we talked about knowing the node count of the tree. So I'll do the same thing. I'll say that create new tree dot node count. At the most I will have these many elements in my stack, because at the most these many nodes I will have to remember. Okay, so now I have created this stack. So whenever I encounter a node, the first thing I will do is I will push it onto the stack because I have to remember it, right? So I'll say that first thing we should do is push the node on to the stack. So I will do s dot push and the current node that I have. Okay, and once you do that, what you should do is you should proceed to the left of the node. So I would say that my current is equal to current dot left. But doing it just once is not enough. You should keep on doing it till you finish the complete leftmost branch. Okay, so we would introduce one more looping construct, and we'll say that do this while something, okay, while you can go to the left, right? So at some point of time you will encounter a null counter on the left when it is the leftmost node. So we'll say that while our current node uh, is not null, we have to do this, okay. So we keep on doing this till we encounter a null pointer to the left. But remember that every node along this path, we have saved it. We have saved it to our stack. So once we do that and we break out of this loop, we are very well sure that our current is null. We are not pointing to anything, okay. So what we should do is we should pop a node from our stack. So I would say that my current will be equal to s dot pop, and now I've got my node, and now I know that I got this because I have explored the left subtree, okay. So this part is done. So now I have to perform the node specific action. So I will write that action here. So in this case we are going to just print, but you might be doing traversal for some other purpose, and then you can have that specific action in this particular box. And once you do that, the next thing that you should do is proceed with the write. And now we don't have to remember the node, okay. So once we are done with the left and node specific action, there is no need to remember the node. So I would just say that my current is equal to current dot write, and that completes the processing for my node, okay. And now let's think about the looping condition that we should have, okay. How long we should loop? One thing is clear that when I am pushing these nodes onto the stack, it means that there is some node which is not yet processed, okay. So I should do this while I'll check if s dot is empty, and I should negate it, okay. So while my stack is not empty, or there is something else. What is it? When I begin, at that time my stack is empty, I have created, but I'm starting with my first node, my tree, my root node. In that case also I should enter the loop, okay. So I'll say that while my stack is not empty, or the current node that I am talking about is not equal to null, okay. So if any of these two conditions is true, I should enter inside, I should keep on processing, okay. Similarly, when I'm done processing the left subtree of my root, and I am done with the node specific operation for my root, I would move to the right of my root. In that case as well, my stack will be empty, but my current pointer will not be null, okay. So it's important to understand that why we need both these conditions, okay. So to understand it better, let's try to run it through the example tree that we have. So we'll do that in the next video.